All right, let's first go over the Sig Fig rules. So the top part of this is asking for examples for each of the 4 rules. When I wrote this out, I wrote the 4th rule as one rule. But remember when we wrote them, we broke it up into 2 parts, like a 4A and a 4B. So let's give some examples here. So for the first one, any non-zero digit is significant. So what that means is if it's any number 1 through 9, it will be significant. So like 1, 2, 3, 4 has how many sig figs? 4 sig figs, yes. And so remember, if I'm writing sig figs, the abbreviation I'll write is SFS, and if it's just 1 sig fig, it'll just be SF. Any 0 between 2 non-zero numbers is going to be significant. So that's the trapped rule. So like 1001 or 1001 with a decimal in there. Both of those instances, those zeros are trapped. So they both have 4 sig figs. Leading zeros are not. They are never significant. Leading, like what comes before, is what that means. So if it comes before a non-zero digit, no matter how many you have, that would only be 1 sig fig. Okay, leading zeros are any of them that come before. Now, when we're actually using these rules in mathematical operations, there's 2 set of rules. The first one is if we have addition or subtraction. So if you're adding 2 sets of numbers together or subtracting them, you're going to use the fewest number of decimal places. Notice it's decimal places, not significant figures. With addition and subtraction, you don't even use these rules. Okay, that's the hardest part kids find. You just literally look at the numbers. So if I've got like 1.0002, now I'm adding 2.1. All right, so I've got 2001.3. How many decimal digits are in this first number? 4. So 1, 2, 3, 4. How many are in this one though? 1. So my final answer can only have 1. So that means you count 1 over. That's why I've been drawing this line right here to remind you, you can only be as precise as your least significant digit in the decimal place. Okay, so any decimal place digits, that's the lowest you can do. So this would be 3.1 for your final answer. Now, multiplication and division, that's when you actually use these 4 sig fig rules. So for multiplication and division, you take the fewest number of significant figures, the smallest number. So if I have 6.00 times 2.0, the number's 12. We should probably all see that. But how many sig figs are in 6.00? 3 sig figs here. How many in 2.0? 2. So your final answer can have 2. Remember, sometimes the significant figures we have to round to just feel off. And those are the ones that are the hardest. So for instance, if I said 6.00 times 2, what would that one be? 10. Okay? This is where your math class would be very, very sad about this. Okay? I know 6 times 2 isn't actually 10, but if we are rounding to the nearest sig fig, this is only 1 sig fig. So the 1 sig fig is here. Look to the right. We're going to stay where we're at, which means this is what we round to a 1, but then you have to put a 0 in there as a placeholder. Okay, same thing. You had 1 on your worksheet where it was like 125, but you had to round that to 1 sig fig. What's 125 rounded to 1 sig fig? So with 1 sig fig, that's 100. No decimal. Okay, it doesn't always feel right, so just remember, if it's to the left of the decimal and you've rounded, you have to put those placeholders in. But no decimal or it adds a sig fig. Okay. So I just wanted you to look back to this front side. So again, this is that practice worksheet for sig figs. This is when we first learned sig figs. What was that, like 2 weeks ago? Feels like a long time ago. It was just me. All right, so this is one of those first examples where you had to do 1 sig fig, look to the right, and put that 0 in the placeholder. This is to lift the decimal. Here, this one's pretty simple, just a 2. and then a 6. This was that hard one where you have to round to one sig fig, so you had to put 2 zeros in there for placeholders, but you do not put placeholders to the right of the decimal because those then would be sig figs. And then 8. I remember when we did this down here, some kids still are a little confused about when you put a number into scientific notation. How many sig figs are in number 4? 3. So when you put that into scientific notation, you can only have 3 sig figs. So it has to be 2.11 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 12. Okay, so 3 sig figs, 3 sig figs. What was it?
Negative 13.
Thank you. The zeros started blurring together on me there. All right, and then again, that would have been 3 sig figs for both. Negative 13. There we go. All right, my back. There's a back side. I printed funny on here. So on your back side of that worksheet, that's what we had due for today. So let's work through a few together. Looks like this. All right, that first I had to do 3 through 5 because those were pretty simple. If you just add those together, and I'm just going to do it on my calculator real quick. So if you add 8.264, okay, minus, sorry, I said addition, minus 7.8, you're going to get 0.464. Remember, addition and subtraction, you can only have the least number of digits to the right. So there's 1 digit to the right, 3 to the right. So 3, 1, the smallest number being 1. So I can only have 1 digit to the right. So I'm going to round where that 4 is. Look to the right. I round up 0.5. A lot of people ask me, do you put the 0 there? It doesn't matter. That doesn't change it. I like to put it just because I see my decimal better, but you don't. Leading zeros never count, so it doesn't really matter. All right. And then the next one, 10.4168 minus 6. Okay, but this is 1 digit to the right. This is 4 to the right, so I can only have 1 to the right. So it comes out to be 4.4 meters. You can't see that. Next one is addition. We can probably see that right off the bat what it's going to be, but I'm going to type it in. 2 plus 15.001. Yesterday I noticed a lot of people don't fully understand how to operate these TI-84s. So if you have a TI-84, a TI-83, any one of those graphing calculators, you can move through your numbers with these arrows. And so say I forgot to put a 1 in there, you can go second, insert 1, and it adds it. If I wanted to just delete that, I can delete it. Okay, so that works anywhere. Again, that delete button just deletes the one you're on, and then clear clears it all. All right. Okay, so that gives me 27.001, but I only have 2 to the right, so 27.00 kilograms. Notice here when we had the same units, that's why I had you guys do these first. If you have the same units and they agree, when you add them, it's simple. You'll have the same unit. If you take 2 pounds plus 2 pounds, you have 4 pounds. Makes sense conceptually, right? When you do it multiplication and division, it looks a little differently. So that's what made these ones tricky. And the part that made these two tricky is you actually had to use factor label method, because you cannot take 2 feet and 2 inches and have 4 feet, right? You have to make sure they're in the same dimension if you're adding. So this one we converted to inches, and we converted all these to minutes. So to minutes. So does anybody in here prefer the train track method? Okay, I'll show you what I mean by that. So for that first one, when I converted 0.68 feet to inches, so 0.68 feet, to inches. This is the standard method. This is how I usually do it. So 1 foot is equal to 12 inches. Okay, so then just multiply those two numbers together, and you get 0.68 times 12, 8.16. But remember, multiplication and division are different rules. So for this step, you would follow the multiplication and division rule. When you go to add them, you use the addition and subtraction rule. So it's 8.16, but I only have 2 sig figs in my given. The sig figs and your conversion factor don't matter because those were in my head. I can put whatever I want for zeros here. I could put 1.0000, right? That was decided by me. So that's why we only use that digit or that quantity. So it's going to be 8.2. My unit is inches. All right, so now I have this in inches, and I have inches, 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 so I add them together. And this is number 1. But I want to show you the bracket method quick too. So if math is something that freaks you out, I know some of us that happens. Sometimes this helps kids not see it as math. I think it just kind of tricks them into thinking it's easier than it. So if we've got feet on top, we definitely want feet on bottom. So I know in 1 foot, there is 12 inches. And then you just take 0.68 times 12 and divide it by 1 if you really want to. Still would get 8.2 inches. Okay, and if you were to do more conversions, you just keep drawing that out and mark it out. Get how it kind of looks like a train track on a map. Overall, fact label method isn't that tricky. You just need to remember, always put the one you want to get rid of on the opposite side of the conversion factor. And then you always have to make sure that your conversion factors make sense, that the top equals the bottom. And then it's fine. That's all you need to do. So let's add these up. So I get 6.201 inches plus 7.4 inches plus 12.0 inches. For those of you that walked in, just FYI, I'm recording. 8.2 inches. It's just my screen though, if you can see. All right, so when I add these up, I get 108. This is the one I messed up yesterday with you guys, wasn't it? It's 33.801, right? And then inches. But remember, addition and subtraction, it's the lowest number of decimal digits. So I only have 1 decimal digit in these 3 numbers, so I can only have 1 here. So that's why this number rounds to 33.8. Because when you look to the right, you're staying where you're at. So 33.8 inches. Always circle or box your final answers so we can see them quickly. Does anybody want me to do number 2? Okay, I'm going to show you my work. I think I did it all. Yeah, so here's my work for number 2. So 1.6 converted to minutes, 1.62 hours converted to minutes. Add them up. You gotta line those decimals up if you want to see it visually. If you just did it on your calculator, just look at these numbers. This has 0 decimal digits, 1 and 3. Nope, you can see fully here. Obviously, 0 is the lowest number there, so you cannot have any decimal digits in your final answer. So that's why it's 12.97 minutes when you add those together. All right, I didn't put the grams on that one. Double check your answers there. Make sure you don't have any questions. We went over these already. All right, now down here, remember when we do multiplication and division, not only do we have different Sig Fig rules, but we do something different with the units. I'm going to type these in my calculator so we don't have to do the long division or multiplication here. So 1.31 times 2.3. How many Sig Figs are in 2.3? 2. How many are 1.31? 3. So my final answer has to have only 2. If I round this to 2, it's 3.0. But what's my unit? Centimeters times centimeters gets you centimeters squared. Remember, like 10 times 10 is 10 squared. Centimeters times centimeters is centimeters squared. All right, next one, I'm going to type it in my calculator again. So 5.7621 times 6.201. But this one has 4 Sig Figs and 5, so I can only have 4, which 1, 2, 3, 4 is where the 3 is. Look to the right, I'm staying where I'm at. So 35.73 meters times meters gives me what? Meters squared, just like I did up there with the centimeters. All right, this one, some people kind of wondered what was going on here. If you have centimeters divided by seconds, it doesn't feel right at first until you think about Other times you do this. If you talk about your speed you're traveling in your car, you say miles